All right, in the first video, we finished up right here, so let's move on now to the next video, or to this video here. So let's say we have these two problems. So yes, I do want you to copy the actual work that I have, and if you'll just copy this right here, we know we can modify all the other information. We know angle 1 equals 24 degrees. We know angle 2 is 3x. And we know that angle 1 and angle 2 are complementary angles. So, if you will, please, if you'll copy the information I have highlighted, that gives us some general information. And what we want to do is figure out the value of x. It tells us in the problem that angle 1 and angle 2 are complementary. So, what I'm going to do is I'm going to start out by just saying angle 1 plus angle 2 equals 90, since they're complementary. All right, angle 1 is 24 degrees, so I'm going to put in place of angle 1, 24. Angle 2 is 3x, so I'm going to substitute in 3x. And now I have my equation, and I can just start solving. We know that we can take care of addition and subtraction. Multiplication and division comes next. So I'm going to subtract 24. Whatever I subtract there, I have to subtract from the other side. 24 cancels out, bring down my 3x. 90 minus 24 gives you 66. So I've taken care of the adding and subtracting. I'm going to move now to multiplying and dividing. 3x is multiplication, the inverse is division. So that means I divide each side by 3. And that gives us x equaling 22. Now, that does not mean that the angle is 22. It just means the value of x is 22. Because we know angle 2 equals 3x. So what I'm going to do is I'm going to substitute 22 in for 3. And that gives us 66. So angle 2 measures 66 degrees. And I can confirm that it's complementary to angle 1 by adding the value of angle 1 to it. We know angle 1 is 24 degrees, so if they're both complementary to each other, that means when I add them together, that should give us a 90-degree angle. So, that is how we solve for this value of x. All right, the next one. This one incorporates the use of a decimal. It's not going to work any differently. Works the same way. So, we have two angles here. We see here that it's a right angle, so that means the two angles together should equal 90 degrees. And let me go ahead and highlight this right here. I do want you to copy this problem down as well. And I'm going to just go ahead and do some highlighting here for where my work's going to be. When we have our test on this week, we will have to do these equations. All right? So we know the first angle is x. We know the second angle is 47.6. Now let's solve to figure out the value of x. So what we're going to do is get rid of the 47.6. So what I'm going to do first is subtract 47.6 from both sides. So 47.6, subtract it there. I'm going to turn the board off and turn it back on real quick. There we go, 47.6. Subtract 47.6 right here. We'll add a decimal and 0. So when I subtract 90 minus 47.6, that gives us 42.4. So x equals 42.4. And how can we check to see if we're right? Well, if we add them both together, 47.6, 42.4, since they're complementary, they should equal 90 degrees. Which they do, so we have confirmed that the x value is 42.4. All right, the next one. See that we have a straight line here? So that means we must be dealing with something that's under 80. And we have that divided into this additional angle, which means we have two angles here that are supplementary. So that means 2x plus 50 should add together to get 180 since they're supplementary. All right, we're going to subtract 50 from both sides. That cancels out. So I'm going to drop down to 2x. That gives you 130. So I now divide each side by 2. So we now divide 130 by 2. And when you do that, you get 65. So x equals 65. We can check our work here by substituting 65 in for x. So 65 times 2 gives you 130. 130 plus 50 give you 180. So that shows that those would be supplementary if x equals 65 degrees. All right, so what I want you to now do is I want you to try these two problems. So if you'll work this one, figure out the value of x, and then if you'll work this one, and see if you'll figure out the value of x. Now this right here, that does not mean that this right here, that does not mean the answer is 2 and the answer is 1. All that's saying is that 1 is referred to as angle 1 and 1 is referred to as angle 2. So if you will work these two, please. All right, so just for a quick review. Two angles are adjacent angles if they share a vertex and a side but have no interior points in common. So let's look at this first side over here on the left, or the first set of angles on the left side over here. We have angle AOB, then we have angle BOC. Those two angles are side by side. The reason they're side by side is because they have the common side right here in common. So that means this angle and the angle right below it means that those are adjacent angles. They're side by side. They share this common side right through there. Okay? All right, let's look over on the right side. If you'll notice this right here, AOB with the red part right here, and angle COD, actually let me make that a little bit better for you. And angle COD, are those two angles adjacent? Well, if you look in the middle, you have this right here in between them. So does angle AOD and does angle COD, do they share a common side? No, they do not. So these are not adjacent. Okay. All right, it says use the diagram of the roller coaster supports on the right side. Let's name an angle adjacent to angle FAD. So I'm going to do the first one or two with you. All right, so let's look at angle FAD. So that's what we're looking at, and our vertex is right here at A. So we want to find one that is right beside it. Well, they have to share a common side, and that common side could be either from A to F or from A to D. Well, there's nothing beside A to F going that direction. So what we have to do is look at this angle right here. Well, this would be their common side, so our common or adjacent angle to it would be angle DAB.